Hi everybody, I'm Katie and welcome back to Alveston Park Friends Star Party 2021. Welcome if you've never been before. If you haven't been, just take a little moment to have a look what's possible here. Down the right hand side, you should see a chat feature where people are saying hi. So hello Star Bear. I'm glad that you've washed your fur. That's great. Clean fur is always good. And also, if you've got a question, you've got this in Ask a Question at the bottom of the screen. That should be just underneath me at the moment. One person has asked a question already. That's great. We'll save those for a while. Thanks, Rowan. And just a heads up about what's going to happen tonight. I'm going to introduce you to Jupiter. Today is Thursday. Thursday has for thousands of years been associated with the planet Jupiter. Jupiter's moons I'm going to leave. I would love to fit everything in, but I can't. What I am going to put in though, and I'm hoping that you'll be pleased about this, Rowan, is a little bit about Neptune. I just thought it fitted in really nicely, but we did a big piece on Jupiter's moons last night. So if you want to catch up on that, you can have a look at Wednesday. That's Day of Mercury. That happened yesterday. A little heads up about what's happening for the rest of the week too, because this is not the end yet. Oh, later on this session, by the way, I forgot the most important bit. Sorry, astronomers. Derby and District Astronomical Society are going to answer all your telescope and binocular questions, and they're going to tell you more about which ones to choose and give you more information on that. Tomorrow is Friday, and on Friday, I'm going to be talking a little bit about Venus. And then you'll have Stardust, which is me again, fitting several billion years into about 25 minutes. And we'll go all through the life cycle of a star. On Saturday, I'm really looking forward to Saturday because then I hand over again to Derby and District Astronomical Society, who are going to tell us all about infrared astronomy and the James Webb Telescope that is going to be launched later this year. This is really opening our eyes up to the universe in different ways using technology. So it is about detecting light that we can't see. It's great. And on Sunday is when we have Ian Russell, award-winning science communicator, come and help us to imagine those enormous distances in space. If any of you are familiar with our normal Alveston Park events, 2020, we actually had a normal event. Can you imagine that? It was in January before we had any restrictions or anything like that coming in. So that was kind of like the last little bit of normality. If any of you are familiar with that, we've had Ian Russell come on a few occasions. You might know him as a Big Bubble Man because he does the most amazing bubble blowing. This is his hobby. It's not his usual job, but they are incredible. They have to be seen to be believed. Hi, Anthony. How are you? So what I'm going to do now is share my screen. Oh, I should be getting good at this. And we'll go and have a look and have a quick tour around the largest of our planets, Jupiter. Now, to the Romans, Anthony's there. I'm sorry, I have to say this. He says, I'm getting quite good at typing. You need a space there. Yeah, you are pretty good, but some work needed. Thanks for that, Anthony. So Jupiter, Jupiter to the Romans was the king of the gods, also associated with thunder. If any of you are thinking of the word Thursday, okay, we've got the Germanic god Thor as well, god of thunder. He's the one with the hammer. He's quite famous for wielding his hammer. And so this little tour, which will take us through not just Jupiter, but Neptune, and also it involves some shipwrecks later on as well. I have in mind a question that was asked very close to the beginning of this week. I have not forgotten it, Kay. I'll answer a little bit, but I'll give you more information in the chat as well. Right, you can see my screen at the moment. I can't. I'll just get back to it. There we go. Here we go. This is Jupiter. This is a picture taken from the Hubble Space Telescope. And if any of you know Jupiter, some of you might know it's the largest planet in the solar system. You could fit about 11 planet Earths across the width. Or if you prefer to imagine it, because it's nice and a little bit smaller, easier to think about, this great red spot. You could fit 2 planet Earths side by side in that great red spot. You could probably stick 3 in if you squeeze them up and put them in a sort of triangular shape. Jupiter is absolutely enormous. It's a gas giant planet. It's also pretty stinky. Hey, you ever thought about what planets smell like? Well, listen to this. If you went to Jupiter, of course, there isn't really a surface to land on. It's made of gas. But if we were to be able to sniff that gas close to the top, you'd get a lot of ammonia. Okay, so I wouldn't go sniffing this stuff. It's but think cleaning products or urine. Yeah, that's the lovely smells you'd get near the top of the clouds. Going further down, you would start to get some more hydrogen sulfide. That's your rotten egg smell. So it's not getting much better there. Further down still, things do get a little nicer in one way, because you come across the smell of bitter almonds or marzipan, and this is due to hydrogen cyanide. It is highly toxic though, so I wouldn't breathe in too much of this stuff or any at all. But that's how Jupiter would smell as you went down. Chris says, yeah, if you want to see this red spot, hurry up as it's shrinking. This great red spot has been shrinking since about 1800. We don't really know why. It's really hard to see here, but I looked on the NASA Hubble site, and they describe this as a bit like a wedding cake. Not the first thing to spring to my mind, but basically it's much higher than the rest of the clouds. It's kind of a tiered structure, and this red spot here is about 3 miles above the clouds below. That's something that really doesn't come out in pictures that easily. What's the small dark brown spot under the red spot? That this thing here, I have no idea. It's probably just kind of like a storm formation. These are all kind of swirling, spinning cloud formations. So yeah, it's a little formation, bit like a storm on Earth. By the way, if we go down past that almondy marzipan-y smell and we go further in, the pressures get so great that you get liquid hydrogen. Okay, so that's the lightest element in the universe sloshing around there. Go further in deeper, and one possibility is that the pressures are so great that those electrons that are whizzing around the nucleus of a hydrogen atom, it's really basically a proton, they can get dislodged and allow conduction to happen. So it can conduct electricity, and that might be contributing to Jupiter's magnetic field. Jupiter does have a ring system. All of the gas giants, Jupiter, Saturn, Uranus, and Neptune, they all have ring systems. Jupiter's is really tricky to see. This is one taken by one of the spacecraft. They had to wait until they were in Jupiter's shadow, so the sun was behind Jupiter, and then you can just see these really, really fine rings here, and they're mostly made up of dust. Saturn's rings have much bigger chunks. Okay, some of those are the size of whales, and by that I mean whales the country, not the big sea creatures, although there are some that size too. And here is a close-up of that great red spot here. Thanks, Chris. He says, I think it's a different layers swirling and breaking through. Was this the brown spot? I thought it was a bit lower than that in the other picture, but that might just be because these pictures have been taken at different times. So, wow. Let's think with all of these storms, you'd get you would get thunder and lightning in Jupiter as well. Lots and lots of lightning. You get ice crystals rubbing against each other as they're rising up. Some of that's water ice, some of that might be ammonia. And as they rub it against each other, it's a little bit like rubbing a balloon on a jumper. You'll rub electrons off, and then eventually, zap, you'll get a massive lightning bolt. So you can see these names, the fact that Jupiter was named thousands of years ago and associated with a thunder god, and it's got enormous storms going on there. It's really, really quite appropriate. Yeah, thanks, Rowan. Neptune storms have stronger and faster rings. I'm going to take you to Neptune now. This is the windiest planet in our solar system. Okay, this is right out. It's the furthest planet from the sun. And here's a storm that isn't there anymore. By the way, the Great Red Spot, that was the official name for the storm in Jupiter. This had an equally straightforward name. This was the Great Dark Spot. Yes, this is your profile picture, yeah, Rowan. Yes, I can see you really, really like Neptune. I do too. And that brilliant blue color, we're not quite sure about. Again, we've got lots of blue from the way that the methane reflects the light in the atmosphere. But Uranus is also largely methane and is much, much paler. So there must be some other substance here causing that deep blue color. I have not been able to find out what it is. I don't think anybody else knows from what I've read either. There's a really nice anniversary that I spotted. In 2011, we had our very, very first star party for Alveston Park Friends. 2011 was the year that Neptune had done a complete orbit of the sun since its discovery by Urbain Le Verrier in 1846. So 1846 to 2011, that period of time was 1 year for Neptune. And I think it's so nice that that coincided with the first star party that we ever had. Yeah, I said it was the windiest world. Okay, 1,200 mile per hour winds here, supersonic, absolutely incredible. It's made largely of hydrogen and helium and methane. Methane is the stuff of cow farts. I will be talking more about cow farts tomorrow too. So you can imagine what Neptune smells like. Yeah, not sure if I want to go sniffing planets. Neptune actually has if you go down through the gas layers, it has, you'll end up with kind of a high pressure, you have melted ices that are swirling around. You can have maybe some of that is water or ammonia, and that's swirling around a solid core as well. And that core is about the same mass as Earth. That's what we think is in the interior of Neptune. I'm going to finish Neptune on another picture. This is a much more recent picture. That great dark spot has long gone. Hi, Ian. Claire's put, are the cows on Neptune blue as well? I don't know. They're clearly hiding. Yeah, perhaps they're camouflage. Perhaps that's it. Here is another spot that has formed recently, and even more recently, just here. This photo was taken last year in 2020. And there's something really weird happening that we don't know why. This spot was moving towards the south, and then all of a sudden it did a U-turn and is going back north again. Nobody knows why. I mean, perhaps the storm's been listening too much to Boris, but definitely something weird going on there. And just here, I think it is a Hubble image, Anthony. I'm pretty sure. There's another little storm coming here. Kay says, Dr. Farnsworth invented the smelloscope to smell planets in Futurama. There you go. I'm not the only one who thinks about sniffing planets. And all of this talk of storms made me remember a question that Kay asked very early on. And by the way, Anthony says he'll not be buying that a smelloscope anytime soon. I want to bring you back to what must have been a storm on Earth about 2,000 years ago, around the Greek islands, because there was a shipwreck of a Roman ship that sank by the island of Antikythera. And by Antikythera, there was found in that shipwreck this beautiful, beautiful piece of treasure. This is the Antikythera mechanism. It's a very, very elaborate piece of equipment that was used to track phases of the moon, predict phases of the moon, planet positions, star rising times at different times of the year. I am going to put a link when the astronomers are talking, and I've got a moment in the chat for you as well. If you want to read any more about this, I've got a lovely piece that was written by Philip Morgan, who I went to university with, and Professor Mike Edmonds, who was one of our university lecturers. It really is quite interesting. I know Philip spent most of his life as a furniture maker and went into do an astrophysics degree later in life as a mature student. And I think that he was drawn to this because of the piecing together. He had a certain way of thinking about this that actually really, really helped. I'll give you more info about that, but this is a really good example of some lost technology. We're still not sure that, thanks Kay for the other article, we're still not quite sure whether it was used for astronomy or astrology. Personally, I think if you go back in time, those boundaries between the two become very, very fuzzy. I mean, where does it begin? Where does it end? If you're looking at stars rising at a certain time to help you decide when to plant your crops, etc., where does that finish? And I was thinking about this and thinking about lost technology as well. I was actually thinking about what I said about the 1980s, which is the decade that I did quite a lot of my growing up in. And this was the decade where the computer graphics, the best computer graphics was using a pi symbol to represent a guard dog. And I've seen pi symbols as guard dogs ever since. Nothing to do with maths. They are guard dogs. You want to stay safe? Have a pi symbol. But that was more than a decade after the moon landings. Now, we all carry around with us, if anybody's got a smartphone, and most of us have, I was one of the last people to get one. You've got way more computing technology in your pocket than people had to get to the moon. And if you ask the question, could people do it that way again? I don't think they could. I think the people involved with that particular, writing the software, those particular systems, they're coming up to retirement, they've forgotten their skills so long ago. We can do this, but we'd have to do it a different way. Our technology has moved on, but we have lost some along the way. This is one of them, and I want to just finish this little piece on something even more incredible. Do not ever underestimate human beings when you look back in time. This takes my breath away. When I was living over in the States, I was fortunate enough to be able to present planetarium shows. This is my absolute favorite thing. I'm effectively a planetarium presenter without a planetarium. One day I will build one, hopefully here in Derby. But one of my favorite shows that I have ever come across was about the Polynesian voyages. Now, they didn't have anything like the 17th century explorers would have had, things like sextants, which would have measured how far north or south they were. I didn't have anything like the Antikythera mechanism, nothing at all. And if you see this really, really vast expanse of oceans, this Pacific Ocean, the Polynesians were navigating this with enormous skill. Notice that I have turned the Earth upside down. Well, of course, that's impossible. You're still looking towards the center of it. Down is towards the center of the Earth. There is no up or down in space, but this might bother some of you, and some of you might think that I've got this wrong. I've very much done it on purpose to just highlight how our brains are set up to and have these little inherent biases right from when we start school. We are trained to put a title at the top of the page, underline it because that's the important bit, yeah. And then as you go down the page, things tend to get less and less important. And we see this all in different parts of our life at the top. Okay, you think about the hierarchy in a company. You have the top, which is more important, of course, than all of people keeping, say, everybody alive in a hospital by cleaning the place. I mean, these are the people who are really keeping everybody alive and well and safe. But we see them at the bottom and therefore not so important. Now, of course, that's all an illusion. I've shifted the world upside down just to highlight that point, because I think sometimes we have to look at things from a different perspective. Now, in Polynesian times, thousands of years ago, no equipment, and we taught people to do this in the planetarium. They use something called the chakra. Now you can hold your hand. Oh, I'll just stop sharing for one moment. In fact, I'll stop sharing full stop. There we go. I'll just click on that. So if you hold your hand out like that, right in front of you, it's going to look really weird. Okay. This is something called the chakra. And what you can do is you can put that and you can measure, you can put them on top of each other, and it's about 10 degrees, I think it was. I can't remember if it's 5 or 10 degrees now, but you could count, I think it's 10, you could count your degrees up, say to the North Star or some other thing in the sky, and you could work out how far north or south you were. Obviously in the Southern Hemisphere, they wouldn't have been able to see the North Star, so they would have used other constellations to help them out, but they would have used the same technique. Now, planetariums are great places, and they come with all sorts of electronic gubbins, which allows you to speed up time or travel north or south. And one of the things that we used to do is just to illustrate what these people could do. We got people to guess when we got back up to our latitude, okay? And we'd say, are you sure? Would you bet on it? Would you bet your life on it? Because that was what these people were doing. They were betting their lives on their ability to navigate the Earth using the stars. If they were a tiny fraction of a degree, maybe half a degree or less off, they would be stranded in that vast Pacific Ocean and almost certainly die. To give you an idea of what would have been required to do that, you would have to not just learn the night sky, you would have to learn the night sky and how it changed every day of the year. Okay, so if you were in January, you would have to think, okay, where's the sky here? It's in January. It would be slightly different in a week's time, slightly different in a week's time. Those would have all been mental maps in their heads. And there is a little technique that I've always been absolutely fascinated by. Some people have still tried to hand it down through generations, but the general thinking is you really have to learn this as a child. I don't think they've ever managed to teach an adult to do this. And they would lie on the bottom of the boats and they would feel the currents, and they would use that and their knowledge of how the currents were in different places to navigate through those vast distances. We're talking about thousands of miles. Absolutely incredible. I'll just share that screen once more just to give you an idea of what they were doing and how they used the stars thousands of years ago. It is absolutely incredible. Donald's put something. Interesting fact, programming the Apollo craft computers was performed by ladies who were highly skilled in embroidery. Can you find out why? Yeah, I'll try and find out why. Chris has said about the Antikythera mechanism. I think these sort of old technologies are actually more ingenious than today. Using smartphone with GPS is too easy. Yeah, Ian has just put something. Bird navigation is similarly awesome and still mysterious. Some evidence that birds also use the stars. I'm going to add seals to that, believe it or not. They reckon seals use the stars to find their way across the oceans as well. And they can train them in planetariums. I don't know how you get to train a seal in a planetarium, but it has been done. I will try and find you a link. I hope you found that interesting, and I'm going to hand over now to the astronomers, and they're going to tell you all about telescopes. So if I stop sharing there, I'm going to invite as many astronomers as I can find up. If I miss you out, just yell in the chat, and hopefully, there we go. Donald, I've invited you. Brian, I've invited you. Chris, I've invited you. Anthony, I'm not going to invite you. Sorry, but you know why. For those of you who are wondering why, for some reason, Crowdcast doesn't like Anthony. Have I missed anybody else? I'll look on page 2.
Peter.
Peter. Thank you.
Hello.
Hello. Peter, there you go. I found you.
Have you got your presentation, Chris?
I have.
Yeah,
okay,
Chris has got a short presentation too.
Chris, if you've got your presentation, sorry, I'm just going to get, I'm going to say bye to the other astronomers, and just so that just until you finish your presentation, if that's okay, and then I'll invite you back up.
Yeah.
Yeah.
Lester.
Yeah, it's a short presentation, and hopefully it will sort of trigger some questions.
Yeah, that's lovely.
So do I share my screen now?
Yep, you can share screen now. That should be fine. I'll tell you when it's up and there.
I've
noticed.
Just a minute. It's not showing the right window at the moment.
Okay.
Just a minute. I'm shutting all the other ones down.
Sorry, Peter. I'm just going to say bye. Hi and bye.
There we go.
Yeah, that's coming up. There you go, ready to start.
Is that full screen?
That's full screen.
Okay then.
Over to you.
Okay. I'm going to just give a quick talk. And interestingly, I'm going to answer the question which is best, binoculars or telescope, and I'll say neither because they do different things. So this is a shortened version of a presentation I gave to the Astronomical Society based on like my sort of first forays into astronomy. And I'm going to share some thoughts and learning. And this isn't an instructional presentation, as I'm most definitely not an expert, although some of the other guys on the panels definitely are. I'm just going to talk about some of the myths and facts about if you're starting on astronomy, what you can and can't do, give you some guidance as to what I found out about the, observing and some of the equipment and what you can do with basic equipment, as opposed to when, people sometimes think you've got to spend thousands and thousands of pounds on expensive telescopes. That's not true. You can, if you want to. And the fact that it's a challenging and learning experience, you're always learning. So hopefully you'll find it interesting and hopefully it will trigger some questions at the end, because it's quite a big subject and I can't tell you which is the best telescope to buy because such a thing doesn't exist, but we'll come to that. So just a few things to start off with. And again, telescope versus binoculars. People think, oh, higher magnification is better and it's everything. You need higher magnification. The answer is no, really you don't. There's a perfect telescope that does everything. No, there isn't. When you look through a telescope, if you've looked through magazines and watched things on the television with Brian Cox and what have you, you think, oh, I'm going to see all these brilliant images through my telescope. Reality is that no, you're not. It's going to be a bit more difficult than that. If you want to record what you see or share it with other people and do a bit of astrophotography, it is quite a challenge. But again, to get good results takes a bit of time and learning, but that's part of the fun and part of the challenge. And you don't need expensive equipment. And that's what I hope to show today. You can get expensive equipment if you get into it, but you can do quite a lot with very little or modest equipment. I'll just put this slide in. I think Katie mentioned it earlier in the week. I'm going back over 40 years when I was sort of courting, in my courting days. We went to Spain for a holiday and we went onto the coast and along the seafront, there was a student who was doing astronomy and he was earning money by setting up his telescope and charging you, I think it was €1 or something. I don't know if it was even euros at the time, but it was very cheap to look through his telescope and he got it pointed at Saturn. And this is over 40 years ago. And I can still remember that moment, that wow moment, and that's what should spur you on. Yes, and you can start with modest equipment and hopefully that will sort of pique your interest. And then you can go on to the harder stuff. So it's a building exercise. But I will warn you, it is quite addictive. And, I could spend a lot more money, but I'd have my wife after me. So I'm going to look at three things. I'm going to look at magnification on your eyes. So you can do a lot with the eyes. You don't even need a binoculars or telescope. I'm then going to talk very briefly about what you can do with binoculars and the sort of setup you can have. And then look at the telescope I've got, which is, as I say, a modest telescope. So the first thing is finding your way around the sky. Bright stars and constellations, and anybody who knows a bit about astronomy will recognize that picture. It isn't actually a brilliant picture, but I picked Orion, as you'd probably recognize, for several reasons. Number one, it shows the different colors of the stars of Betelgeuse versus Rigel at the bottom there, and the red one at the top. And people don't always notice that. And also, looking at the constellations, and again, we spoke about these early in the week. This is Orion the Hunter, but actually, it's just to be honest, it's just a set of stars in a group in a particular orientation. But if you look at his shoulders at the top, his legs at the bottom, and his belt, they're really useful to learn how to do star hopping to find your way around. His belt points off to the right towards Taurus and the Pleiades, and off to the left to Sirius, I think it is. So, learning to find your way around it's a treasure map to find fainter objects, because these are obvious ones. Finding the more difficult ones, you need that sort of thing. To learn to find your way around. People are probably aware that you need at least half an hour in the absolute dark, sitting outside with warm clothing at this time of year in a chair, before you can really start seeing the fainter objects. And there are aids and books that I've used that I found quite useful. A classic book that a lot of people say you should get, and I've got a copy of it, is called Turn Left at Orion. It's a really useful book. I mean, other books are available, but this sort of shows you, if you notice here, the view of Orion, and then it shows you what you can see at various magnifications. So it gives you a lot of information to help you find your way around and to tell you what you're looking at. I've taken this screenshot of my phone, And you can see this stellarium, which was talked about earlier on in the week. Sky Map I use quite a bit. There's a Messier catalogue where I think we've spoken about there's lots of different catalogues of objects that you can follow. One thing about that is be very careful using those, because if you're all nice dark adapted and you switch your mobile phone on and look at your smart screen, you've got another half hour before you can see anything again. So magnification 2 is binoculars. So what's it good for? It's good for looking at the larger planets and the moons. If you look at Jupiter, you can actually see the moons, and with a 10x50s or 15x70s, you can actually start to see a little bit of features, and you can certainly see even Saturn. You can see that it actually isn't round, and you can see some star clusters, nebula, and galaxies. And the one thing that surprised me about binoculars is you can look at a part of the sky and you can see a few stars. You look through binoculars and you can see so much more just at that sort of slight magnification, and the fact that you're using the binoculars as a bit of an amplifier. And again, the same aids to find your way around, but because just your binoculars there and your wide view, you need to be able to star hop to find things that are a bit fainter, because you have to stare at them from quite some time and use averted vision, which we'll perhaps talk about later. One thing I found, at my age, my hands are not very steady. And if you do buy a pair of binoculars, you can see in the little inset photograph there, you can purchase, a lot of binoculars have a cover on the front between the two main parts, and you can take that off and screw in a little holder so you could fit it onto a normal photographic tripod, and you can get a lot better view with the binoculars being steady. Although I must admit, looking up high is quite tricky, but sometimes you can lean back and use the tripod as a steady. So and I'm whizzing through this fairly quickly, but we will come back and it's going to be a question and answer session. I don't want to be talking for ages. So this is my telescope setup, and it's a 5-inch telescope. It's a Maxutov Cassegrain. It's on a computerized mount, and these are the key parts that you can see there. It was asked about the other day. The go-to mount it's got a computer in it and electric motors and sensors, and you set the tripod level, you zero everything, and then you use the handset to point to several stars, and that sort of calibrates it so it knows where it is. And then after that, it's got a catalogue, I think, of about 49,000 objects. Some you'll never see because they're below the horizon, but a lot they are. And the telescope will sort of move around and point at them. And I found at lowish magnification, it's normally within view, and then you can sort of nudge it to get it to the right place and then increase your magnification. And one of the good things about these, although they take a bit of setting up, is once it's set up, it will track, so it knows whether you're looking at a planet or you're looking at the moon or you're looking at an object in the sky, like sort of a double star or nebula, and it will actually track it, so it will keep it in view for quite a long time, even at fairly high magnification. The other things you can see there is you need. I've got a power tank, as they call it. You can spend a lot of money in an astronomy shop, or go and get one of these jumpstart type things from Halfords for about half the price. And as I say, with your telescope, you can use it at fairly low power, and you could call it a light bucket, so it sort of makes things that are very faint a lot brighter, or you can use it at fairly high power and magnify the detail, so you can make very small things look a bit bigger. And as for the mount, there's different sorts of mounts and different types of telescopes, and I'll talk about those briefly. One thing before I go ahead is you can see at the top there, I've got an eyepiece in there with a sort of right angle to make it more comfortable. But you could also, and we've spoke about this before, you can get an adapter to put a single lens reflex camera or a bridge camera. A lot of people have bridge cameras now. You can get adapters for those. Or as you can see in that picture there, that's looking at end on the telescope. I've got a little USB camera that I link up to my laptop and sort of use that to take photographs. So with the current setup that I've got, and as I say, it's fairly modest equipment, particularly compared to some of the, what you could spend your money on, is, binoculars 10x50 give a good bright view, useful magnification. The tripod's essential, I've said that. It's quick and easy to set up. You get nice wide views of the bigger and dimmer objects, and you can see the other side, the sort of magnifications you can actually get. You can work out the magnification from the eyepiece in millimeters and the telescope focal length. And as you can see, you can go from looking at large objects to smaller objects or dimmer to brighter. For me, that telescope was it was a reasonable price. It was a good all-rounder. It's got limitations. It's quite good as a sort of general telescope in my view. And there are other makes and other types, and I'll talk about it in a moment. The go-to Altaz is, yes, it's not as quick as, it's not a 5-minute job to set it up, but once you've learnt it, it's okay. And it's okay for basic photography and basic observation, and they're the sort of roughly the sort of magnifications. I mean, I always hate general rules because general rules is always exceptions, but they're the sorts of things that you can look at the different magnifications. As I say, I apologize, I'm whizzing through, but I'm just aware that we want to get onto the discussion, and we can always come back and look at the slides again. I would say there's no such thing as a perfect set of binoculars or a perfect telescope. They're all different. They all do different things. They've all got the strengths and weaknesses, how easy they are, how portable they are, how expensive they are. So do get some advice before you, or talk to the experts, or read up on the, on the internet is a wonderful source of information now. Just to talk briefly about the telescopes, and again, we might come back to this if people have specific questions. Quite a busy slide here, but you can see at the top, basically there's the 3 types of telescope and the diagram of the optics in there, and they all do basically the same thing, but in different ways. The very thin bluish one is a refractor, so it's basically got lenses in there. The middle one is a Newtonian, so it's got a mirror to collect light and bounce it back up the tube and out at a right angle through the eyepiece that you can see on it. And there you can see a general term for these folded up telescopes, as they are, which have a lens at the front and the back. A mirror at the back and a lens at the front, which sort of points bounces the light out the back. Catadioptrics is a general one, and that's the type I've got. Okay, and I say they've all got the advantages and disadvantages. I've actually got a Newtonian, the middle one, an 8-inch one. So again, it's quite good as they're very cheap to buy to get a lot of light gathering. And then at the bottom we've got the different sorts of mounts they can have, and of course you can have any sort of mount, any sort of telescope on any sort of mount. The middle one is probably the cheapest and easiest, and if you've got a large telescope, you can get going at a relatively low cost with a Dobsonian, which is basically made of MDF and got bearings on it, so you can move the telescope around and up and down. An Altaz one has the similar movements, and I'm getting into specialist area now. Be very careful what I say. The disadvantage of an Altaz is that the stars actually move round the North Pole star. And therefore, even if you've got a telescope that tracks, the sky is turning in your view as well. And the only way to counteract that is to have an equatorial mount where one axis is pointing towards the North Star, and the other axis allows you to move. The other axes allow you to move around. And if you get one that's tracking, then it will track exactly, and the view won't be turning, which doesn't really matter for observation, but does matter if you want to get into astrophotography on very faint objects. And I think we were talking the other day about, you know, exposure times of minutes. Then you would need one of those sort of mounts. And as you can see to the side, there's pros and cons to everything. You know, how big they are, how much the cost, focal length, and the weight, etc. So some of the accessories, fairly quick and easy. I use a neutral density if you're looking at the moon, because basically it's so bright. So they're fundamentally like a filter that you put in like sunglasses. It was spoke about the other day. I've got an anti-pollution filter that filters or tries to filter out the street lights. I live in Oakwood in Derby, and this is the yellow sodium lights everywhere. So you can counteract that a little bit. One of the things you can do if you buy a telescope, these are the standard eyepieces that come with it, and they're okay to get you going. But if you, they're okay to get you going. But if you want to spend a bit of money and you've got a decent telescope, investing in some better eyepieces really pays dividend in my view. You get a better view. It's often a wider view rather than looking through a tiny little lens, and better eye relief, which is the distance I can be away and still see, and that's good if you have to wear glasses. And I've put thermal underwear and warm clothes because at this time of year, waiting at least half an hour and then spending lots of time out there, it can get quite cold. These are the sorts of things you can do. The one thing I like looking at is the moon, and I'll show you some examples of pictures I've took of the moon in a moment. You know, you could think, well, I've looked at the moon, I've seen it now, but you know, looking at the different features, and as each of the phases of the moon, and particularly where the terminator is, which is where it turns from light to dark, moves across, you get a completely different perspective, and at different magnifications as well. You can observe the planets. You can see the planets reasonably well in the telescope I've got, and as I say, it's a fairly modest kit. And then start looking at the sort of more difficult nebulas, galaxies, and star clusters, which we've spoke about. I must admit, one thing when I started astronomy, I didn't realise until you start looking, is the number of different coloured stars you can get, and the fact that you can get variable stars, and actually there's a lot of stars that if you look closely, they're actually 2 stars or even 3 stars, and quite often contrasting colours. So I've got my bucket list, and they're obvious things, and I'm going to sort of whiz through these. A warning there: I do want to get into looking at the sun, but you have to be extremely careful. Never look at the sun directly, or certainly don't look through your telescope or binoculars. You need special filters, and I would say get specialist advice. But just briefly now, I'm going to talk about the sort of things you can achieve from a photographic point of view. I've got a Sony camera, which is a single lens reflex camera. And then I bought a USB camera. So that was my first attempt, and hopefully you're seeing that and thinking, well, I can just about recognize that as Jupiter. That was my first attempt at it. I was quite pleased I got something. It was difficult, but I got it. And then I sort of had another go with my USB camera, and I achieved that, which I'm quite pleased with. I then, just to show you can, and we spoke about this the other day, you can get a mobile phone and just point it down to the lens and hold it carefully, or get a holder and you can look at the moon. That was taken with me with my single lens reflex camera, and that's actually a mosaic of 3 pictures. And then with my USB camera, I zoom in a bit more, and then at very high mag, and just to show you that visually and with a camera, they're the sort of sizes you can see. And although Helicon is 16 miles across, if you look carefully, you can see stuff that's a lot smaller. So, you know, get your setup right and you can see stuff that's sort of 2 or 3 miles across, which I think is pretty amazing. You know, I just love doing that. So help and information, join the DDAS. You know, we're a friendly lot, as they'll tell, I think you've seen. There's lots of people can share their expertise. I like books. Sky at Night and Astronomy now. I subscribe to Sky at Night. Patrick Moore's Guide to the Moon is a brilliant book if you're interested in the moon. You know, it's got loads and loads of information and loads of individual targets. You know, so you can sort of look at that. And then there's other books that you can get. So at that, I'd say thank you for listening. And then sort of, I guess we're going to open it to questions. Can't hear you, Katie.
Is that better? Can you hear me now?
I can hear you now.
I was just saying thank you so much for that. It really, really was fascinating stuff. Telescopes and binoculars, they're not my strong point, so that was really helpful for me, and I'm sure it would have been helpful for a lot of other people too. I'm just going to invite people up. Donald, I'm inviting you now. Here you go. And Brian. Yep, and if I go down, Peter, I won't forget you this time. Here you go. I feel like I've missed somebody and I can't remember who it is. Have I got everybody?
Anthony.
Sorry, Anthony. Anthony's still here. I can try. I can give it another go.
I see we've got some interesting questions.
Yeah, let me have a look at them.
Yeah, I can answer one of them.
Yeah.
Jupiter, did you look like that without stacking, and what did it look like? The answer's without any stacking, it looked pretty rubbish. The technique I used is with the USB camera. I actually used video, and I think some people call it lucky video, or lucky photographing. And I set the camera to take about 100 frames a second, and ran it for like a couple of minutes, and then use software that goes through and picks out the best frames, because unless you've got perfect atmospherics, it's wobbling about, it's going in and out of focus because at that sort of high magnification. And somehow, and the other guys will tell me if I'm wrong on this, I think when you look at it through your telescope, you get all that, but your brain sorts it out. Your brain can cope with it. But when you just take a single photograph, unless you're really lucky, it looks awful. So that's probably about a couple of thousand frames, picking out the best 50% of them, and then stacking them and averaging them to remove the noise and remove, sort of increase the detail, and then put it through and sharpen it up a bit, and then Photoshop just to give it that last tweak, if that answers your question.
Brilliant. Thank you for that one. I want to ask this one. I know, Donald, you've answered this, so perhaps this is one for you to take on. This is from Claire, who says, I've heard it said that Jupiter is a failed star. Could you comment on this, please?
Not me. I'm just an enthusiastic amateur.
No, it's not a failed star. It's
I just thought so. Yeah.
There are planets larger than Jupiter. You know, not in our solar system, but exoplanets that are larger than Jupiter. It's just made up of the same material as the Sun. Basically, it formed at around about the same time as the Sun, so it's just made up of more of the same stuff.
Okay, thank you for that. Let's go on. There's one from Peter here. It's a really good question because I've been thinking about this too. Why are there no green stars? I've got no idea. Anybody?
Is it probably that green is? I'm guessing now that green is normally associated with copper and those sort of metals, and you generally don't get heavier metals, so you get the blues and you get carbon, which gives you the reds, and the whites, of course. But green is normally an indication of copper or something like that, and I don't think you get copper in stars. I don't know. I'm guessing.
Yeah, interesting one though.
If you heat an iron bar, a metal bar up, it starts when it gets quite hot. It looks red, doesn't it?
Yeah.
And if you heat it up even more, it goes from red to sort of brighter and brighter, and it starts to get white. And if you heat it up even more, it goes to blue. And those are the only colour of stars you see. You don't see green stars because if you look at the spectra coming from the stars, and the thermodynamics of the stars, you can never ever get green. The camera can never pick up green. It can't distinguish green because it's picking up the red and the blues. And red and blue will give you a white colouring. If you go online, some people will say, well, I can see a green star. It's actually an optical illusion. You can get some green hints if you've got two stars quite close together. But you will never, ever see a green star because of the thermodynamics of black body radiation, believe it or not. It's a function of physics.
Thank you for that one.
It could be something to do with the atmosphere as well. Surely.
No, you can't see. There are no green stars, Brian. Really, there are no green.
Oh well,
stars.
it must be my camera then.
Yeah.
Yeah.
If you see a green star, it's chromatic aberration on the lenses due to the lenses of the telescopes and cameras.
Yeah, Peter, which is the I forget which. There's a double star, and one looks orange and one looks turquoisey. Which one's that? I forget this.
That's yeah.
Is it Alberio?
In Cygnus, Alberio, yeah.
Alberio is a lovely, two different colour stars. I think there are quite a few pairs like that where you've got, a lovely colour combination in the sky. I mean, it's an interesting exercise to hunt them out and do a train spotting exercise yourself.
Yeah.
And find those.
Brilliant. This is a telescope and binocular question. I like this one. How can you make your telescope see more surface features on planets?
If you, sorry, Dawn, did you want to answer that one?
We can't hear you.
We'll come back. Mars is
Can anybody do sign language?
Mars is really the only
Yeah, 3 to 1.
that you've got that you can see the surface of.
Donald, I'll close it and invite you just in case it helps. Sorry, carry on.
Yeah, Mars is the only planet you can see the surface of. So you're really looking at the clouds on anything else. Venus, you can see some structure in the clouds, and certainly you can enhance the views of Jupiter and Saturn by using particular filters. Against the question in the question answers, I put down a link to a website which has actually got some lovely information about the different kinds of filters you can buy and what which planet they are best suited to looking at.
Can you hear me?
Yeah,
yes,
we can hear you.
Yeah, sorry.
I'm just going to ask this one. I'm just sending over to questions that just come in from Toby, aged 8. Hi Toby, how are you? He says it looks like there are more craters on the moon than Earth. Is that right?
Well, a lot of the Earth is continually renewing its surface. Okay, so we have volcanoes and things like that are replenishing the surface. Now the moon has stopped doing that now. It's no longer replenishing its surface. So any craters that are on the moon now will have been there for a few billion years possibly, and any that are created now, any asteroids or meteorites and things that hit the moon, they'll still be there. Whereas the Earth, plus the fact that the Earth's covered mostly in water, and a lot of the asteroids just land in the water, the meteorites land in water.
The other effect is wind and water, and because the moon has no atmosphere, there's no weathering of the surface, or minimal weathering of the surface, unlike the Earth, where the surface has been modified through wind, rain, and volcanic activity. So that's why there were a lot of craters in the originally, but most of them have now been flattened effectively. So.
Brilliant. There's one telescope here from Ian, telescope question I should say. Could you explain quickly how to set up an equatorial telescope mount?
No.
Not quickly, no.
It's very first. Well, you've got to get the mount pointing towards north to start with, and set the latitude or up and down bit, if you like, to 53 degrees, and then you should be somewhere near. You know, it's not going to be perfect, but it'll be somewhere near.
What I would
set it up properly, it's a bit convoluted.
What I would suggest every year, the club has an evening where we show beginners how to set up telescopes.
Yeah.
The other opportunity is we have gone out to people's houses to help them set up that Christmas gift that they've never been able to get to work before. So once COVID is over, please invite us, and we'd be more than happy to help you with that.
Or bring your telescope out to the observatory, and we'll do it.
And we'll set it up for you.
We'll have a Barbie.
Yeah, I guess that's one of the benefits of the old house that it's relatively easy to set. I've never set up an equatorial, but I can imagine what it's like. But an old house, as long as you've got it reasonably level and you start off at 0 and with the telescope pointing north, and then you put in the latitude and longitude you're at and the elevation and things like that, and then point it at a few stars, and that all corrects each other out. And it isn't simple, but I think it's easier than an equatorial.
Yeah, I'm just going to add to that. The other little thing is to actually set one up where you've got the north-south line actually in the concrete.
Right.
When I've had to set things up over in the States, that was already there. I cannot remember how to do it now, though. Thank you for that one. Just having a nosy. It is one about space missions to Jupiter. How do space missions to Jupiter and moons deal with the extremely high levels of radiation, magnetic field, and immense gravity? Anybody want to?
Excuse me, just put me on mute.
Have done. No. Does anybody want to? Go on.
There's a satellite orbiting. Right. Is it Jupiter or I can't remember? Sorry. It's looping in and out, coming very close to the planet, because of the strong radiation that it's going to experience, because of the magnetic fields it's experiencing. So it's coming in, whizzing around, and then shooting way out again just to get out of it. and taking these stunning pictures while it's very, very close. But it's using the very strong gravity to its advantage when it does that. Like a slingshot, when you get these slingshot missions that use the planets to get out, further out into the solar system, or even sometimes as they are with Bepi Colombo, trying to get closer to the sun. So gravity is not something to be feared or worried about. You take it into account because you can use the gravity to get you to other places. And some of the satellites around Jupiter and Saturn have used their planet's gravity to get out to the moons and take these stunning pictures of the moons around. So it's but the radiation is a problem, and the magnetic fields can be a problem because they can interfere with the radio broadcasts that are being sent to the satellite and coming back from the satellite. And they can also damage the structure of the satellites themselves. So you have to be very careful.
Thank you for that. Anthony's also put something up. Modern spacecraft have specially radiation hardened and shielded components. Thank you.
Can I do a book review quickly?
Absolutely.
It's related to some of the questions that were asked earlier about navigation and animal navigation. There was something mentioned a little bit earlier. Somebody said, how on earth do all these animals find their way around? If I can point you to this book.
Oh, I'll make you bigger as well.
Okay, it's called Incredible Journeys. Okay, Incredible Journeys by David Barry. Okay, I can put a link to this. This is an absolutely amazing how lots and lots of creatures, ants, bats, seals, what have we got? Butterflies, turtles, use the magnetic field of the Earth, the Milky Way, the stars, all sorts of things to navigate around the planet. Unbelievably clever, these animals are. They knock us into a cocked hat.
If you want a local, thank you for that. That was fantastic. And I'm just going to add a local example of that. I don't know if any of you have heard of the King of Rome. The King of Rome was a pigeon who, sometime in the 1800s, I believe, he was sent to Rome as part of a huge pigeon race. Anyway, this pigeon, there was a huge storm, and many of the pigeons were lost. But the King of Rome was the first one to arrive back, and there's a lovely local folk song that has been written about that. The pigeon itself has been taxidermied and is in Derby Museum as well. It's a lovely story from a not very well off pigeon fancier, right close to the centre of Derby. Look into that. But to get from Rome 200 miles, well, more than that, hundreds of miles back to Derby, it's just incredible. They can sense things that we just can't. We haven't got those skills. Right, I shall have a look.
I think Rowan wants this one answering, doesn't he?
Rowan keeps asking the same. He's got this question up on the questions and in the chat line. He's quite determined to get an answer.
Go on then.
Yeah, which nebulas can you see through a telescope without photostacking?
I've got to say, I've quickly typed an answer. If you get a good Messier catalogue, and there's plenty on the internet, they have values for the surface brightness. And what I did is I started at the brightest and I've been working my way down. But where I live in Oakwood, where there's too much ambient light, it's very difficult to sort of get down. But
the trouble with nebulas, it's gas that's lit by the stars behind it.
Yeah.
So it's not like a cluster, a globular cluster, or an open cluster, something like that, which is the starlight that you're actually seeing. It's the colour of the gas, if you like, or it's the gas that you're seeing. So it's very difficult to see any nebula other than probably you through a decent telescope at the observatory. You'll probably see the crab, but it'll only just look like a fingerprint on a piece of glass. Obviously, the Orion Nebula.
I was going to say the Orion Nebula.
Yeah, you can see the Andromeda Galaxy. You might see one or two of the galaxies actually.
Yeah, you probably see quite a few galaxies on a dark night.
But that starlight you see that you're actually seeing, it's a combination of all the starlight. Although it's travelling billions of light years.
Nebulae tend to be spread out across the sky a little bit more, and as Brian says, it's called a surface brightness. So it's like a value given to the combination. It's not like a star pinpoint. Where you can say a star is magnitude 5 or 6 or 7. I think the Crab Nebula is magnitude 8. So technically, you should be able to see it with a decent telescope. As Brian says, it'll just be a smudge in the sky.
A lot of the nebula you won't see because it's too faint. And Rowan keeps going on about photostacking, but you have to photostack.
Yeah.
Because your eyes and your brain can't process the information quick enough. Your eyes are only a few millimeters across. So you're not getting a lot of light in there. What you need is a big bucket, basically, to get the light in so that you can see more.
If you think how fast sorry, John.
So you have to remember that these are incredibly small and dim objects, and they're only shooting out a few photons. Those few photons of light have to interact with your retina on your eye. The only way you can enhance that is through either magnification or amplification. And how we amplify it is using stacking. So we take lots of photographs of the same image and we add them together. We're not falsifying what we're seeing. What we are gathering is more of the light. That's why it's incredibly important that you understand the difference between the size of a telescope and its magnification. It doesn't matter how much it magnifies, because if it's a bad image, it will just make a bad image worse. What you're trying to do is get as much light from that object in the sky into your eye so you can resolve more information. So please don't set aside stacking as something that's bad or naughty or false. It is far from that. What we're doing is using it as an amplifier, just as you amplify sound. We're using it to amplify the visual signal. Does that make more sense, Rowan? But there seems to be an awful lot of negativity about the photostacking, but it is not a false image. It's a true image that we use to identify other properties of that system.
I think that was a brilliant answer. Thank you for that. And that was really clear to me as well. We don't have within us the ways of sensing the universe around us, even that some animals have. We've just talked about birds being able to sense that magnetic field of Earth, but what we have got is an incredible intelligence and resourcefulness that we can use to gather more information so we can see more and we can find out more. Let's go on to another question.
Katie, before we do that, I don't know if this will work, but just for Rowan, I mean, it's a sort of stacking. I've found the original video on which I stacked the best photos and got Jupiter. I don't know if it'll run on screen, but you can just see what the quality looks like before you stack it. I don't know if if it's worth trying that.
Yeah, sure. Let's go ahead. Have a go.
So let me just do that. I don't know if this will work. Share my screen, application window. It's not showing it. Close that. It sometimes doesn't. It's not showing it up at the moment. It's not showing. It's not showing the window. I've got to try that. Try. Just a minute.
We'll have to make sure the application is open before you start to share.
Yeah, I've got the application open, but I can't. Oh, there we go. There we go.
Oh, brilliant.
Try that. Can you see a video now?
We can. Yeah, that's brilliant.
Right. It's not playing. I'll press play and see if it works.
Yeah.
Is that showing the video now?
Yes, it is.
Yeah, it is. Yeah.
So and you can see it coming in and out of focus. That was the original video. So it's stacking, but it's lots and lots of frames at about 100 frames a second. And you can see there's a lot of noise and a lot of dithering, and you can see just then it sort of goes out of focus and in again. And I took all those and picked the best ones. So back to Rowan, it's not cheating. It's picking the best moments, if you like. If you're watching it, it's wobbling away because that's the atmosphere. So you take all those and then you average the best ones.
That was
Did
really
that work?
Yeah. Okay, I'll have a look through the questions again.
He says the original video looks good enough.
Not for me.
Wait, I can assure you, Rowan, once you start getting into this, if you take a video like that, the next thing you'll say to yourself is, that's not good enough. I'm going to do that one again and again and again. You're never satisfied. Sorry, Rowan, you're never satisfied. You'll always want to do it better.
Yeah.
It's addictive, I'm afraid.
The only thing that will stop you is your budget.
I think there's a slight difference here about difference in stacking and then photoshopping. The processing of the image, enhancing the image. There's a difference there. A lot of these pictures use. I mean, the Hubble, for instance, Hubble telescope uses black and white images and then the colours added afterwards. So.
Can I do a screen share? I'll show
absolutely.
I'll show you a quick before and after.
Yeah, that's really cool. Thank you, Peter.
Okay.
Katie, can I excuse myself, please? I need to leave now.
Absolutely.
Okay.
Thank you so much for your input and your answers. It's been
That's a pleasure.
great.
I'll see you all tomorrow night. Thanks everyone for your contribution.
See you later, Don.
Thank you.
Okay, can you see that one?
Yeah, we can.
Yeah.
All right. So this is one called the Cone Nebula. Okay, the Cone Nebula, and that's just a set of stacked images. So it looks pretty grim, doesn't it? But when you put it into a Photoshop equivalent and bring out the colours, that's what you get.
Whoa.
Okay, so that's before, and that's after.
Is that what they call stretching?
You're bringing out the colours by using a process called curves and levels.
Yeah.
So this is for Rowan's benefit. If you get that image and you think, I'm not satisfied with that. There's more information in there. I can get it out. And when you get that,
Going off, Pete.
You've got gas emitting light, and you've got some structure over here. You've got some other clouds over here, and you've got thousands of stars in the image. So I'm going to stop there.
Just a really quick question that's come up on the chat from Rowan, and I think it's quite a good one. What do you use to photostack images? And thanks to Anthony, who says the object is there, you're just bringing out so you can see it in its structure. But yeah, what method do you actually use to photostack those images?
Well, go on, I'll let you answer that one, Peter, because you're,
Right, okay.
you're the expert.
I use a program called Nebulosity to do all my stacking. Nebulosity, you can buy Nebulosity. There's a free version of Nebulosity you can download, but you can't save the images. You can't get any decent images saved with the free version. It's the only piece of software I've bought, and it was about £70. And I use free software to take the images, and through my telescopes or through my camera. All this free stuff, all downloadable off the internet, and it's absolutely super software to take the images. And then once I've got the images, I process them in a package called Nebulosity. And Nebulosity will stack them all together. You can do other things to the images when you're stacking them, and it'll give you one image at the end, and then I put that image again. Nebulosity will do this for you using these processes called levels and curves. They are in Photoshop. They are in a free package called GIMP Shop, which is like Photoshop, but GIMP Shop is free. You can download it, and you can manipulate those images and bring out the color from those what look like just ordinary dull black and white pinpoint of stars, and you can get all that rich color. You can get blues, you can get greens, because some of the nebula emit green light from the molecules that are there, and the reds and other colors. So nebulosity I use for all my stacking and processing most of the time.
That's really, really useful. Thanks for that. I think we're going to have one last question, because, I mean, this is quite specific, but I think the answer will be relevant to a lot of objects. Why is Nereid's object so irregular?
Sorry, can you say that again, Katie?
Yeah, it's why is Nereid's orbit so irregular? Did I say that right, Nereid? So what would make a asteroid or a moon have a really irregular orbit?
The chances are it's a captured asteroid. If something is quite irregular orbiting something, then your first port of call, your first sort of guess at it is it's going to be a captured object.
Yeah, or it's influenced by something else, such as, you know, I mean, our moon's got an irregular orbit. You know, that goes out and in. Mercury goes out and in. That's very exaggerated, Mercury. You know, so most things. I think there's only Venus actually that's got a pretty circular orbit. Everything else has got a elliptical orbit.
Brilliant, thank you for that. Anthony's just adding, maybe it may have been gravitationally disrupted or captured. Yeah, all good stuff. Okay, astronomers, thank you very much. If there's anything else you want to say, just stick your hand up and wave at me. Otherwise, I'm going to...
Rowan had a quick question. Not as good as Nebulosity, but if you're a real cheapskate and you don't want to pay, there's two quite reasonable programs, but they don't do everything. Is Registacks and Auto Stackert are free programs, but they all do different things, and I think people say that nebulosity builds it all in. If you have them, then you need all the other processing.
No, because I can't process videos in nebulosity. I use Registacks, and Registacks is absolutely brilliant for doing videos.
Yeah, that's what I used. Yeah.
And I don't use oak because I don't know how to do it.
Well, I didn't 3 or 4 years ago. It's a journey of discovery.
I want to make a cloud dispersion filter anyway. I'll make a fortune.
Oh, absolutely.
Brian.
Sorry?
In one of the programs, you can overcome the atmospheric dispersion by doing an RGB line, and it does it for you.
So I think we're going to say bye for now. We will be back tomorrow. We're back with Venus tomorrow, and I'm just going to say bye to you, astronomers, whilst I finish up. So thank you very much for your help. Thank you so much for that talk, Chris. That was really, really good.
Okay, no problem.
And I'll see some of you tomorrow. Yeah, we're back with Venus, and then I'm going to go through the whole life cycle of stars. Thank you all so much for coming. Thank you, Star Bear, who says we've been on an incredible journey. Thanks. Bye, everybody. Bye, Judy. Bye, Joy. Just thank you so much for coming, and thank you to all of those who keep coming back, as well as any newbies that might be coming too. Thanks, Kay. That's really appreciated too. I'll see you tomorrow with Venus, and then don't forget about Saturn Day. I'll be talking about the hexagon. Now, I have not forgotten about that hexagon question. I did spot it. And then on Sunday, we have the wonderful Ian Russell, who is going to come and tell us he's going to explore with us, I think, of how to really imagine those enormous distances in space. And that's something that I never could quite grapple with all of the time I was studying space at university. So that is going to be absolutely fantastic. See you tomorrow. Same time, same place.